Hi, I'm Gillian Benn, the Training Manager with ESS. I'm here today with Joe O'Sullivan to give all of you maintenance practitioners out there an overview of what a Lean Maintenance 4.0 program looks like. As a training provider of choice with Engineers Ireland, we're partnering with their maintenance society, META, to deliver a Lean Maintenance 4.0 program that is aimed at ensuring that all relevant stakeholders who have any involvement with maintenance fully understand the challenges that lay ahead of them in the form of Industry 4.0. For the next 5 slides, Joe O'Sullivan, the chairman of META, will share some of his experiences and he'll take you through his Lean Maintenance 4.0 journey. During Joe's career, he's been heavily involved in the design, implementation and sustainability of Lean Maintenance 4.0. The roadmap he has developed has identified a number of opportunities for organisations. After Joe has outlined his journey, I'll tell you a little bit about ESS and I'll explain the various services that ESS and our data provide. We'll focus on training and finally finish up with next steps should you wish to begin your Lean Maintenance 4.0 journey.
Hello, my name is Joe O'Sullivan. I am Chairman of META, which is a special interest group for maintenance, reliability and asset management practitioners within Engineers Ireland. Our vision is to drive best practices in maintenance engineering and asset management in Ireland. With the support of Engineers Ireland and Maintenance Professionals ESS, we hope to fulfil our mission of sharing our expert knowledge through events and networking. Over the years, I have seen the stature of maintenance change dramatically. I've seen maintenance evolve from a necessary evil that companies had to endure to the current perception that maintenance is one of the few remaining opportunities for companies to gain a significant competitive advantage. With the current advances in robotics, artificial intelligence and machine learning, we are in the midst of the fourth industrial revolution called Industry 4.0. Activities such as maintenance are not exempt, and like every other sector, we too have to embrace the required synergies between humans and machines. In this presentation, I will tell you about my personal story, how in 2008 I began a search for the best possible maintenance strategy. Like in the Monty Python team, I undertook a quest to seek the holy grail of maintenance excellence. My involvement in maintenance over many years has taught me that for any maintenance organisation to function, there are 3 core elements that must work in harmony. No matter what sector of industry you come from, you must manage your systems effectively. You must have a strong leadership team at the helm, and your efforts must be linked to the business to deliver the return on investment the company has made for you. Whilst many of my peers accept this theory, the challenge for most of us is how to link all 3 together. If you search this topic of Lean Maintenance 4.0, you will find a limited amount of information. It was this lack of information that drove me to answer the call for more research to be done in this field. My research traces the roots of maintenance to Henry Ford, who introduced the moving assembly line in 1913. The conveyor system positioned equipment in series. If one machine stopped, the whole assembly line stopped. It was a well-known fact that waste drove Ford crazy. Ford was well aware of the cost implications of losses in materials, motion and time. It was this hatred of waste that drove Ford and his team to be the first to carry out scheduled interventions on pieces of auxiliary equipment to prevent the units from failing. Ford was the first to drive this type of scheduled repair and replacement into the world of manufacturing. After World War II, 2 significant concepts emerged from the original Ford model of maintenance. The first of which is called Total Productive Maintenance, or TPM. The origins of TPM can be traced to a company supplying Toyota called Nippon Dinzo. Advances in automation increased the demand for maintenance personnel, a resource that was very scarce in Japan after the war. Therefore, management decided that routine maintenance of equipment would be carried out by the operators. This in turn freed the maintenance crew up to work on essential maintenance, continuous improvements and build RAM, namely reliability, availability and maintainability, into the design of the new equipment. This advancement in maintenance gave birth to the term productive maintenance. But the Japanese automotive industry was not the only sector to be influenced by Ford's new maintenance philosophies. Civil aviation was one of the first industries to experience the devastation of equipment failure. As a result of numerous failures, the airlines looked to increase their technical resources to do more maintenance. This strategy resulted in inflated costs and only served to increase the unreliability of the aircraft. The response of the US Department of Defense was to commission 2 United Airline engineers to investigate and identify corrective actions to prevent these equipment failures from happening. The resultant report from Stanley Nolan and Howard Heap formed the platform for what we now know today as Reliability Centred Maintenance, or RCM. Their seminal work would change the face of reliability engineering as we know it today. They concluded that no direct correlation existed between equipment failure and age-related wear. They concluded that 90% of all failures were random and could not be protected by preventive maintenance alone. Many conventional preventative maintenance tasks achieved nothing and in some cases proved to be counterproductive. Unnecessary maintenance interventions increased the probability of failure. Therefore, the conclusion reached was, if it isn't broken, don't fix it. Completing my master's degree in maintenance engineering and asset management was a very beneficial undertaking. But because I had some previous experience in lean initiatives, it became obvious that a lot of wasteful practices existed in the traditional heavy engineered maintenance sector. My curiosity in the research and my search to find excellence in maintenance management led me to undertake another master's degree, this time in lean enterprise. Again, while there are some excellent philosophies and learnings in lean, because of the way TPM had evolved over time, some of the technical strengths of reliability engineering, which drove successful maintenance management strategies, were found missing from TPM. To answer the call for more research to be done in this field, I decided to extract the best bits of lean and the best bits of reliability engineering to gather the best tools and concepts possible. Before I move any further, there's one other part to the Henry Ford story worth mentioning. While the Ford manufacturing model was technically powerful, the way in which he treated his employees was fundamentally flawed, to the point that Ford had succeeded in alienating his workforce. In the middle of the Ford branch, you will see the term division of labour. This ideology looked to eliminate the time-consuming and costly training demands of the traditional craftspeople and replace them with low-paid, unskilled workers. Toyota recognized this lack of humanity in the Ford management style, but also rejected the traditional craftsman system in favor of autonomous working groups. As lean continues to eliminate waste, it continually looks to shift the workload from the craft to the unskilled worker. So it makes sense that the strongest resistors to lean became the craft workers who associated lean with redundancy. The central message I have for all stakeholders is not to be threatened by the challenge of Industry 4.0. Industry 4.0 can be a threat if engineers, maintenance and operators do not take that step forward to develop their skills further. For me, advancing skills and personal development is the best form of job security. On their return to Toyota in 2010, Womack and Jones set about answering a question that they had not fully understood in their previous visit to Toyota 10 years earlier. On their return, they unearthed 5 principles that looked to guide the actions of every lean initiative. These 5 principles were to specify value by listening to the voice of the customer, mapping systems and processes, identifying and removing bottlenecks, allowing value streams to flow. Waste elimination allowed customers to pull product on demand. This removal of waste invariably frees up resources to perform additional value-added tasks. A constant pursuit of perfection must be embedded in any lean culture. And finally, respect for people is at the heart of all work activities. In 2017, The Economist magazine reported a fundamental shift in the current manufacturing strategies of companies who historically looked to low-cost, low-technology manufacturing in Asia. Driven by advances in software, robotics and 3D printing, sportswear manufacturer Adidas are availing of new, increased, innovative and high-tech engineering to increase its manufacturing capabilities. They call these new factories speed factories, which are now located in high-cost areas such as Germany and the US. The primary driver behind this new manufacturing strategy is not only to reduce labour costs as much as shorten the supply chain, and in doing so reduce delivery time to days rather than weeks. My research findings support the notion that lean philosophies can combine successfully with reliability engineering, but the challenge still remains: how best to implement a Lean Maintenance 4.0 program. If you are setting out on any journey, one of the first questions you need to ask is the journey necessary? Will it add value? The next step is, can I map out the easiest possible route to get there? Other secondary questions could ask, do I have enough finance and resources to make the journey? And last but not least, do I have the drive and enthusiasm to reach the final destination? If the answer is yes to all the questions, then you will need pointers and milestones to track your progress and ensure that you remain on track to reach your goal. It was with this imagery of a road journey in mind, combined with the work of the academics such as Womack and Jones, Mustafa et al. And John Cotter, where I began to develop my own Lean Maintenance 4.0 roadmap. The starting point on this Lean Maintenance 4.0 roadmap is to specify value. Value is always defined by the customer needs. First step under the heading of value looks for top-down management support. The change leader needs to generate a sense of urgency about the task in hand and get the right teams together to deliver transformational change. Change typically comes about because there is some underlying crisis. This crisis is currently how to embrace the technology Industry 4.0 brings. Step 2 suggests that an audit benchmarked against current best practices will identify the gaps between the current state and ideal state. Step 3 calls for training of the initial guiding teams on the grounding principles of both lean and reliability engineering, so this team are competent to make the required decisions. Having reviewed the audit findings and the gap analysis, Step 4 looks for this guiding team to design the remainder of this Lean Maintenance 4.0 roadmap to map out a journey that is correct for you. Under the heading Map, the goal is to identify non-value adding activities. Performing a criticality analysis at this stage helps weed out the most critical assets and ensures the correct level of resources and support is focused in the right area. Step 6 introduces the value stream mapping process. This is a simple but real eye-opener and real eye-opening experience that makes all the actions of any product or service really easy to see. A balanced scorecard enables effective planning, selecting, monitoring and diagnostics of key departmental goals. For performance metrics to add value, all data measured must be used. It must have value to the user. It must listen to the voice of the customer, and finally it must act as a guiding mechanism to enable top-down, bottom-up communication to flow. Step 8 is all about understanding the various lean and reliability engineering tools available. Selecting the correct tool and applying them correctly is a critical component of the entire process. Under the heading of flow, waste is removed from the value stream. Reliability-centered maintenance is a process used to determine what must be done to ensure that any physical asset continues to do what its user wants it to do in the present operating context. RCM is an excellent tool not only to identify the best failure management strategy, but it also plays a huge role in increasing employee engagement and improving cross-functional teamwork. Step 10 calls for the removal of the waste identified in the value stream mapping and RCM studies. Once this waste has been removed, the remaining steps should flow smoothly with no interruptions, delays or bottlenecks. At this stage, increasing frontline operator asset care, or FLOAC, should further increase operator ownership of equipment. It will help to further break down any silo thinking that may exist. This can be one of the greatest challenges for any lean maintenance program to overcome. As discussed during the mind map, the benefits of getting this element right is a huge part of this program on a number of fronts. Industry 4.0 brings with it many new benefits, but for me perhaps the most important is knowledge. The concept of tacit to explicit knowledge sharing is a real opportunity for companies to take advantage of the benefits Industry 4.0 brings. An effective failure reporting, analysis and corrective action system, or FRACAS, will ensure that important data and information is captured and fed from the factory floor as effectively and as efficiently as possible. Knowledge management prevents staff from constantly looking to reinvent the wheel. Knowledge management and prescriptive maintenance are now becoming a key component in maintenance strategies, and for those who embrace it, there are vast rewards. For those who don't, they'll almost certainly get left behind. Having removed wasteful practices and increasing the reliability of the equipment, this phase of pull looks to make the best use of the freed up resources in operations, maintenance and engineering to work to drive continuous improvement programs and, as required, build RAM into the design of new equipment. Step 13 looks to the development of process improvement teams, cross-functional teams working together to jointly focus on eliminating all non-value added activities. Effective change management supports the search for low-hanging fruit, especially in the initial phase. Creating short-term wins can be achieved cheaply and build faith in the change project, attracting those who are not actively involved. It also takes power away from the cynics. Step 15. We must avoid starting too many projects at once, since it ultimately leads to chaos and confusion. At this stage, we are entering the sustainability phase where it's easy to run out of gas. So this step is all about maintaining a solid and constant momentum, stick with the program, and close out actions one by one. In step 16, we look for a positive trend in the performance metrics, which should be evident at this point and should act as a motivator to see the final journey through. Last, but probably the most important phase, is this constant pursuit of perfection. Accomplishing phase 1 to 4 is a great start, but the fifth phase, embedding lean thinking into a maintenance culture, is a worthy challenge for any change leader. Standards define the minimum requirement and set expectations. If the standard defines the what is required, then guidelines define how to complete it. Standardization is a key component in sustaining the gains already achieved. Step 18 suggests that once these standards are in place, they now need to be audited on a regular basis to ensure that the right things are being done the right way, all the time, every time. The second last step looks to market and sell the many benefits of implementing this Lean Maintenance 4.0 program. Top down, bottom up, all stakeholders need to realise the tangible benefits and return on investment achieved by undertaking this journey. Step 20, the last step, calls for determination never to give up. It's worth noting that in any change effort, culture comes last, not first. Change has to be embedded in the very culture of the organisation if it is to stick. The Lean Maintenance 4.0 program does not stop here. New ways of working must continue to be explored. In truth, the quest for this holy grail of maintenance excellence is a never-ending cycle and demands a never-ending pursuit of perfection. This roadmap looks for skills in the design, implementation and sustainability of a Lean Maintenance 4.0 program. Should you choose to bring your organisation on a similar journey, know that ESS and their data have a range of training programs and provide expert support for all the steps on this roadmap. They provide change management support. They provide audit, training and consultancy. They provide training on the fundamentals of lean reliability principles. They can facilitate and support the initial startup phases. They provide training and support on criticality analysis. They will show you how to do process and value stream mapping. They provide training and the overview on key performance metrics, KPIs. They also show all the various lean and reliability tools that are available. The important reliability study, they support and provide training on this. They also can facilitate and support your frontline operator asset care program, or FLOAC. When it comes to failure reporting and corrective action systems, or FRACAS, ESS have training and support for that. And also they provide support and guidance to develop process improvement teams. When it comes to the development of standards and guidelines, ESS provide that support, and also they provide support to market and sell the real tangible benefits to the boardroom. For the next number of slides, Gillian will outline the type of training and support services ESS and Airdata offer.
And now to tell you a little bit about who we are. The ESS Group incorporates engineering support and services and Airdata environmental services. ESS is in business for over 27 years. We're headquartered here in Limerick with offices in Cork. We work with people to implement and carry out maintenance and asset management and to optimise performance. We believe in fostering long-term, mutually beneficial relationships with our clients, supporting their maintenance and asset management journeys. Our services include maintenance, outsourcing and recruitment. We offer complete management services. We provide consultancy and auditing. And we partner and support clients through maintenance, asset management and technical training. We also have a facilities management division. Our customer portfolio spans life sciences, food and drink, engineering, utilities and manufacturing sectors. And now to tell you a little bit about Airdata. Airdata was established in 2001, headquartered in Cork with offices in Limerick. The team specialise in HVAC maintenance, clean room validation, commissioning, compliance for over 16 years. We can cover chiller maintenance related to HVAC equipment as a one-stop shop maintenance solution for both HVAC and associated chillers. We offer indoor air quality services and we support our pharmaceutical and healthcare clients with training. There are multiple users of our services across Ireland, and again, we foster long-term relationship with them with a strong client base in pharmaceutical, medical device and healthcare industry. And now to focus a little bit on our training division. Our training is available in-house at your company or at public venues in Dublin, Cork, Galway and Limerick. We're running an average of 60 courses every year, being a training partner and support to over 400 clients each year. We work with hundreds of Irish and multinational companies across every industry sector. We are accredited by BQAI to the ISO standard 9001-2015. We offer QQI courses and we run City and Guilds programs. And we're registered training providers with Engineers Ireland and the Institute of Asset Management. And finally, we'll just finish up today with next steps should you wish to begin your Lean Maintenance 4.0 journey. Our public programme schedule is available on our website. The link is listed here. And specifically, we'll begin our rollout of our Lean Maintenance 4.0 series, starting with the Change Management Workshop in April 2019. So for any questions or bookings inquiries on public or in-house training that we provide, you can contact us by email at training@ESS Ltd or the landline and mobile number that are listed here. Thank you for your time. I hope you found the presentation beneficial.